identified. The direction of the average goes up, goes down, then goes up a bit, then comes down. At this point, the margin and the average should be the same. At that point, that's a tendency. The margin and the average should be the same. Right? Okay, now I have to graph the average. Well, should I start from up here or down here? Or graph the average should be there or there. Just up higher or lower. Higher or lower. It should be lower, because when the average is rising, the margin should be higher to push it up. That is up. The reason the average is rising is because the margin is higher. Then down, then up, then down. Make sense? When APL is rising, MPL is higher than APL. That's the rule. When it's falling, APL is lower. Right? At the inflection, the two are the same. That's the inflection. When it's rising is higher. When it's falling is lower. Rising higher. Falling lower. When it deflects, it's equal to right. That is a APL graph. Does it make sense? Okay. A bit of geometry, but that tells you what the margin is, what the average is, and you can see the margin guides the average. The average is nothing but an outcome of how the margin looks. Right? Make sense? Okay. Anyway, if it makes sense, perfect. Otherwise, we'll come back to it again later. This is the best of them. Let's see if you have a version of this one. I think you get a version of this one. You get a version of this one on the quiz. I made up a function. You will see the function will give you standard short-run production, but at the expense of long run. So you cannot have a function that gives you both sides. If you fix the short run, you have a problem with the long run. If you have a long run fixed like complex CS, you're not going to have the short run. So here, I'll get the short run I want by a made-up function, but we're going to have problem when we do long run. Make sense? So we're going to start with the short run. That gives us nice short-run picture. In the short run, the capital is fixed at 10, so this is our short-run production. 1,000 L squared minus L. That's a short-run production. I need to find MPL. That's 2,000 L minus 3 L squared. I need to find APL, which is QL. That is 1,000 L minus L squared. Make sense? I identified marginal product labor and average product labor. You can see both of them rise and fall. That's rise and fall, that's rise and fall. That's a standard sort of short-term picture. The average rises and falls, the margin rises and falls. Similar to the basic that we did before. If you want to graph the short-run production, a typical one, we need 3 points. One, when production is inefficient, the maximum labor we can use thereafter is inefficient. For that, what should we do? If you want to identify where the production thereafter is inefficient, what should you do? You put MPL equal to 0, because anything more, that's inefficient. So let's do that. That is point number one. You cannot use more labor because thereafter the labor is inefficient. Alright? Okay, what's the second one? The second one is when MPL is maximized. i.e. when DMR sets in. i.e. DMR sets in. For that, we can just maximize this one. Take that one, maximize it. And that's the way we maximize it. That will give us 2000 minus 6L. That will give us the second important point, which is where MPL is maximized. What else? Based on the initial graph we had for the short run, we identified three important points. Where production thereafter is inefficient, where MPL is maximized when DMR sets in. What else? There's another point. Yep.
MPL is from APL.
That is when APL is maximized. So you're right. But you can say, rather than that, you can say where APL is maximized. I can do it two ways. I can use what you said, which is put MPL equal to APL and solve it. That's one way of doing it. That's what you should try. Or I can just maximize APL directly. It's the same thing. The second one is easier, right? So I'm going to do that. I'm going to maximize APL directly. By taking derivative. Try this one, you get the same thing. Put MPL equal to APL, you get exactly the same thing. So you can do it both ways. Just maximize APL by taking derivative, or put MPL equal to APL. You will get 500 in both cases. Alright? Okay, now we can graph the whole thing. Let me graph the whole thing. That is our production. That is L, that's Q, that is APL, NPL. I identified first what MPL is 0. That was 2000 divided by 3. That's the highest labor you can use. You cannot use any more. Then I went to identify the peak of MPL. That is when the tertiary graph turns. When the graph turns, you have maximized MPL. So that's sort of somewhere there. That was 2000 divided by 6. Right? The margin goes up, then falls, all the way to this. That is the maximum MPL at 2006. This is where DMR sets in. Anything more will give you less produce. Right? The last point was where APL is maximized. The APL is maximized at the tangency. So that is where APL is maximized. Let's use a different color. That is where APL is maximized. Yeah, there. The APL goes up, maximized, and comes down. That is 500. I graph a short run production function. That's typical short run. So we can have a function that gives us typical short run. But you will see in a bit, we're going to miss the long run. All right? There will be a problem in the long run, but we fix the short run. Make sense? Anyway, you can make up a function that gives you nice short run production, but at the expense of long run. All right? Does that make sense? Okay. You have an example of this one. Very close to it. Yeah, very close. Very close. So make sure yes, very close. So make sure you know what is going on, right? I just changed the numbers. Actually, you have the easiest one of all these quizzes, because others have more difficult variant of it. I change it beyond numbers, right? Here, it's just numbers change. Make sense? Okay. Part C. Long run. Get MRTS. Tell me what is going on based on MRTS. Then graph. Then graph. An isequence. When it says representative means just choose a Q and solve it. Right? So I'll give you a Q. In the sample, in the quiz, I gave you a number. So I did not give it to you because otherwise everyone gets something and very hard to mark, right? No. On the quiz, it says graph a representative. So let me fix it. If you see the quiz, use Q equal to 50. So that is the I sequence I wanted to grab. Because otherwise it will be hard for a T to mark, right? Okay. Let's see how we do it for 100. For 200. Before I need MRTS. MRTS is MPL. MPK. What is MPL in this case? 2KL minus 3L squared. That's MPL. Make sense? What is MPK? L squared. MPL, MPK. Make sense? Okay. Question for you. Starting with the capital. Is the capital always efficient? Is the capital always efficient? Yes, this is more than 0. Always efficient. Basically means it will always replace labor. That's the meaning of it. In the ISEC one, you have more capital, it always replaces labor. Right? Okay. Does capital follow DMR? Do you have the initial margin returns to capital? Yes or no? This is constant. This is constant, right? The DMR does not hold. If you increase the capital, no matter how much you use, that's how much it returns. It doesn't fall, right? It's constant. DMR does not hold for capital. That's the capital. DMR is not required, so we're fine with that. DMR is not required. It's just typical, right? It's fine. Nothing wrong there. What about MPL? That is MPL. Is the labor always efficient? Is the labor always efficient? Yes or no? Is the labor always efficient? No. It will only be efficient if this is more than 0, but this can be less than 0. This can be equal to 0. Labor, not always efficient. If you use too much of it, it will be inefficient. If you cross a certain point, it will be inefficient. What's that point? It will depend on the capital. Depending on the capital, you can find it, right? But depending on the capital is the limit to how much labor you can use. Right? Make sense? Okay, so be careful when you graph the ISEC one. The ISEC one is not going to look like this. It's not going to be convex smooth origin because the labor can be inefficient. It basically means if you use too much labor at some point, the ISEC one will turn up. They become inefficient, right? You should find a point where ISEC one turns up and cross this out. Make sense? So be careful, you cannot say that's the ISEC one. Right? You have to identify where it becomes inefficient and stop it. How do you identify it? That's the way you do it. I'm going to solve it and you'll figure out when I finish it why that's the case, hopefully. Take the ISEC one you want to graph. That is what you want to graph. Was it 200 or 100? 200. Write the production function. Make sense? Take this one, solve it for K. Take this one, solve it for K. What do you got? Am I right? Is that right? That's right. Take this one, plug it there. That tells you The maximum labor it can use. Because anything more you violate that condition. Right? So let's do it. See what we get. 200 equal to 3L to L minus 3L squared. That gives you what? That gives you, that's the power of 3 now too. My mistake. That's the power of 3. And was this the power of 2? I think this is 2. I missed that 2. This is the production, right? So that should be L3 to the divided by 2. So now I can get L. That should be 400 to the power of 1/3. How much is that one? That's the maximum labor you can use. If you want to produce 200 units, anything more is inefficient. What do you got? If you want to produce 200 units, that's the maximum amount of labor you can use. Anything more, it's inefficient. That's the limit of the number of labor you can use. How much is it?
7.368.
7.368. So let me graph it, show you what I did. That's the labor. That's the capital. I want to graph this isequence. The isequence looks standard. I can use any capital I want. I can bring down the capital, replace it with labor until I arrive at this one. Thereafter, I cannot use more labor. It won't substitute for the capital anymore. That's inefficient. So thereafter, I will end up with rising. So basically means the extra labor I use requires extra capital now. Make sense? So the isequence is fine. I can use the capital to replace for the labor up to certain point. If I use too many labors, then I cannot do it anymore. I.e. the isequence will tend up, i.e. the labor becomes inefficient. So you have to cut off the isequence. At the inefficient side, that purple one is the only correct isequence. The rest is not correct. Make sense? That's the meaning of what we did numerically. Does that make sense? Okay. Try it. There's an example from it. It's very hard to do stuff that is only for the fun. I will have a midterm next week, right? But that's the way it is. It's only because of Mondays. Blame them. It's not them. Blame the register office. If you have multi-section, don't put anything on Monday. That should be the rule, right? Okay. Anyway, last one. Last one. Doesn't take a long time. We sort of did it, but without numbers. I'm going to do it with numbers here. I gave you a production function. What's the name of this one? What do you call it? What's the name of it? You don't call it perfect complement. That's consumer theory. You call it fixed proportion, or if you want to be more intelligent, what do you call it? Laurentier. Everyone calls it Laurentier. In the world of economics, everyone calls it Laurentier. So they don't call it fixed proportion, they just call it Laurentier function, right? Make sense? And sometimes they write the Laurentier, I've seen it, sometimes write it this way. But everyone calls it Laurentier production function, right? That basically means this is the only efficient production possible. That means you have to stay on this line. If you aren't on it, production will be inefficient. Right? That's the meaning of it. The mean means if you depart from that line, you get nothing. And since the production has to be efficient, you should depart from that line. Right? So let me grab that line, then go further. That is the line you have to be on. Only efficient production is on this line. If you depart from it, you get nothing. That's the meaning of mean. Right? Suppose a company set the capital at 100. A fixed capital. So fix the capital at 100. That is 100. Then what should they do? The only efficient production becomes higher. How many labor? 20 labor. That's what this says. Make sense? See, if the company fixes the capital, they will be forced to hire 20 labor. If they are more, that's useless. If they are less, they have too much capital. So either way, it will be inefficient. Make sense? So they'll be forced to hire 20 labor and produce how much? And produce how much? Well, put the numbers in the production function. 4 multiplied by 100, 20 multiplied by 20. What do you got? What's the minimum of those two? That is 400. That is the only efficient production. So at this point, okay, I ran out of battery, I think. No, let's do this. It's not a battery. I think Microsoft froze, which is normal. Every day I have to have 3 times. Anything less than 3 times, that's not allowed. You basically end up with producing there. How many units produced there? 400. Right? If you would have used more labor, that would have been useless. Make sense? More capital, that would be useless too. That's the I sequence you're on. The I sequence give you 400. The L-shaped nature of it tells you that if you depart from that combination, you get nothing. Not too much. If you fix the capital, see, this is what we did. We fixed the capital. That forced you to use 20 labor. And that forced you to produce 200. There is no other efficient production. Yep.
How is Q 400?
What's the minimum of 400? 400? Well, that's the answer. That's the function. It says minimum of those two, you end up with 400. Right? That basically tells you both have to be the same. If both are not the same, you either have too much labor or too much capital doing nothing.
So like,
The minimum explain that you shouldn't be there. That's what it says. The minimum tells you you have to be on this line. If you're not on this line, you either have inefficient labor or inefficient capital. Make sense? So if you have, it's like me saying, if you have 1 taxi, you must have 1 driver. If you have 2 drivers, the second one does nothing. That's the mean. Yeah. What?
I have a question. I didn't understand how you got Q.
Where we got 2?
Q.
You mean 400? That's his question.
I didn't understand your answer.
Okay. Q is minimum of 20 multiplied by 20. That's one part. And what's the other one? 4 multiplied by 100. That's 400. That's 400. What's the minimum? That's how much you produce. You produce 400. Yeah.
What if it was like different, like not the same?
Then you have too many labor or too much capital, which is impossible. That's inefficient. Say if you would have used, just for the sake of it, if you would have used 40 labor, then that would have been 40. That would have been 800. That would have still produced 400. So this extra labor didn't do anything. You don't go there because you assume the production is efficient. Yeah.
so if it says max,
Max? We don't have max.
there is no max.
That's not a relative function. It's not made up. This is basically actual world production function. Some production use fixed capital labor in an exact proportion, like a driver and a taxi, right? Let's try to characterize that. If you put max, you're inventing something else that's used somewhere else probably, not in the auto production. Make sense? Anyway, okay. So that is that. Question for you. What is the short-term production function? In the world of Leontief production function, what's the short-term production function? What is QSR? If someone told you, write the short-term production function for Leontief function, your answer would be, there is no short-term production function because if you fix the capital, you fix the labor too. You cannot change it. So you cannot change the output. Make sense? A short-term production function is fix the capital, change the labor, change the output. That's a short-term. But in the long-term fold, if you fix the capital, you fix everything. So there is no short-term production function because if you fix the capital, in this case at 100, you fix the labor at, what was it, 20, and you fix the output at 400. You cannot change the output because you cannot change the labor. No production function defined in the short term. Make sense? That's that. Make sense? Okay. Next one. That's your production function. That's the I sequence. What's the MRTS for it? You might say MRTS there is 0. There is infinite. You may say one wing is 0 and the other wing is infinite. Is that correct? You may say depending on where you stay on the I sequence, it might be 0 or infinite. Is that the correct answer? The answer is no, because the wings are inefficient. You're never there. You're always at this point. Perfect, I shouldn't say perfect. Fixed proportion, you cannot change the labor for capital and vice versa. There is no MRTS. MRTS is rate of exchange. Does not exist. It's just a one unique technology. You cannot transfer capital and labor and backward. You cannot alter the technology. Make sense? Okay, so MRTS, which is defined as this, does not exist. MRTS is this one. Does not exist. Is not defined, I should say. It's not defined for it. So don't say 0 or infinite, because you're never there. These are inefficient. Here labor is inefficient, there capital is inefficient, and production must be efficient. So you're stuck with this dot. And a dot does not have a slope. That's the mathematics of it, right? There is no MRTS defined for fixed proportion for Leontief, right? Okay, anyway, we're done. Next week will be reviewish. It's not reviewish. We'll do mock test, which is the latest iteration of midterm. By that time, you should have studied enough. Should look familiar, except for not easy parts. Right? So I should, oh, I know this stuff. If everything look unfamiliar, that's not a good idea. That's not good at all, right? You won't have time. So make sure you study enough. When I go through it, I'll spend more time on the difficult, I shouldn't say difficult side. The side that needs more time. Nothing is difficult, right? Nothing. That test in the summer, I'll tell you the average when we do it. I'll tell you the average, right? Anyway, we're done.